really a technical process that requires not only expertise, but it requires very, very good computing hardware to be able to process for the most part, whether it's Revit, SolidWorks, Navisworks. Most of these softwares require an engineer and an engineering level computer to be able to access the software and work on the software. So what we did is created a software based on a gaming mesh engine. So the idea is that you can create with even higher fidelity an environment that is more like the realistic representation than if you were to even do the scan to BIM process, because scan to BIM, you actually have someone physically modeling, building boxes, creating these digital assets, and there's a margin of error in that process. For us, it is fully automated, so you can take up to terabytes of point cloud data and have a working deliverable on which you can perform all of these same engineering functionalities and have that deliverable ready in the same day, even if it's terabytes of data, right? So that discrepancy of amount of time where taking a point cloud, taking weeks or even months to model these complex environments has now been reduced to a timeline of same day. So that gives you an idea of not only the ability to create these environments quickly, but we have also created an environment in which the point cloud is now reduced by about 90 to 95% in size and requires minimal to mid-grade specs on a computer to run. So what the notion of this is to democratize the data, to bring everyone, technical or non-technical, to the table, to allow stakeholders from industries that have never worked with point clouds before, that have never seen digital twin environments before, to now access these environments. You no longer have to fly people across countries to visit their facilities. It is now much easier to get people in these environments and working on these environments in ways that just wasn't possible before. So without further ado, I'll hop right into the demo, show you guys what the software looks like. So there's two components to our software. One is the cloud component, on which essentially any first iteration of the point cloud that you process with us will be published. This is where you will access that first iteration. So this is the as-built of the facility. And from the cloud, you can create links for people to access any iteration that you create. So anyone who you want to invite into your environment does not actually need the software downloaded. You can create a link and anybody can access it easily from a web viewer. So it is very easy to share this data with anyone you want to give access to, so that you can do this remotely without having them download any kind of software. All they do is follow the link, and on the website they can see through the viewer the environment you're trying to show them. As far as most of the engineering functionalities go, this is done on the local file, which can be downloaded. And so at the end of the day, you own the data here. So you download this and you can work on it offline. And most of the engineering functionalities of our software are done here on the local file. So once the software boots up, the first thing you see, so you have the ability to reduce the quality. Reducing the quality does not by any means affect the measurements that you'll be taking or the engineering work you'll be doing. But if for whatever reason you're streaming it to a lot of people, or you're just running it on a very bad computer, which is, it's rare to, most computers can run this software pretty well, but you could decide what level of quality you want to run. You can decide if you want to do it in meters or feet, and once you hit start, you get into the environment with this top-down view. And from this top-down view, there's certain things that you can do. So this is essentially what would be classified as a 2D view. So if you, for example, wanted to create an as-built set of floor plans, you can decide where you splice these floor plans. You can decide the level of quality you want the floor plans at. You can create multiple layers. So deciding the space between these layers here on plan height. So you can create varying levels of asset density so that you can, depending on what you're looking to do, export with different levels of density. Once you've decided, hey, this is the floor plan I want. For example, if you want to compare the CAD floor plans, so the ideal floor plans as they were built, everything 90-degree angles and, beautiful straight walls, and then you want to overlay it with the as built, you can do that. You can decide where you want to clip it and then export it as a DXF into CAD. If you want to get a better visualization here of the asset density, you can enter orthophoto. You could even export this as a set of floor plans if this is more convenient for you. And so then from there, I'll go into our 3D view. So this here is the mesh. And I'll reiterate that, I'm streaming this to quite a few people, running this from a mid-grade laptop. And I'll show you why this gaming engine makes it so easy to do that. It has what's called a hierarchical level of definition, so HLOD. And just to give you an idea, this is no longer a point cloud. This is the mesh. And how it works is that as you navigate through the space, you have these polygons that will render at a higher level of definition the closer you go to an object as you move through the space. And if you're not looking at anything within the space, it does not render. So the idea is what's in your field of vision is rendering. The closer you get to an object, the more it will define. Think of it, it works like your eyeballs do. You look at something, it will get into focus. You're not looking at something, it's not there, right? So this allows your computer to free up that GPU capacity that in most other softwares is being taken up because they require the entire space to be rendered to even access an environment. So here we do not. You can navigate it freely and it renders as you go through the space. Any questions?
Yeah, do you want questions verbally or in the chat?
Yeah, no, verbally. Stop me at any point. I'm happy to make this interactive.
So is this using like Amazon Web Service, or where does this actually live?
Yes, so we process with AWS
Okay.
exactly. So the information that we get is processed with AWS, and it is hosted on AWS servers. So in North America, AWS in Virginia, in Europe, AWS in Frankfurt.
Okay, so this image that you're actually streaming from, this is streaming from an AWS file server, or like where's it actually being rendered? You know what I mean?
Yeah, so we have our processing technology, but this can live offline, right? So we can download the file
Okay.
and then just have it processed natively on your computer. But if you're streaming it online, it'll be streamed through AWS servers.
Okay. And then sorry, follow-up question.
No problem.
Is there like we scan power plants, we do a lot of that, right? We scan, industrial facilities, power plants, our scans are 500 scans, 700 scans for a given project. Is there a limitation on number of scans that we can dump into this
No,
platform and get out of it, or?
no. So that's one of the big benefits of using Prevu3D is, like I mentioned before, we can take terabytes of data
Hmm.
and have a rendered deliverable the same day, right? So for us, there's no size limitation. The pricing model is built around how much data we process and host. So
Okay.
what will be impacted is price, but there is no limitation on the amount of data that we can process.
Okay. So when I don't know if you're going to get to this or not, but it's like we go out, we scan, and we come back with a bunch of, raw scan data files from the scanner itself. We use a Leica scanner.
Mhm.
Um, do we then we upload that into your platform, or
Yes.
how do?
So this was actually taken with a Leica, an RTC 360.
Okay.
So yeah, basically you get those scans. In the registration process, you do what's called structuring. So you hit basically a small checkbox that says, do you want to structure them? And structuring, what it does is it will, in the E57 file, include the scan locations, so the photospheres. So here, as you can see, so these are the photographs that are taken by the scanner at the same
Yep.
time while it's scanning. as well as the so the photographs and the scan locations, as well as the lasers being shot out at those scans in that point in time, right? So that's
Mhm.
what a structured data set is. So that's what we require, a structured E57, and then you submit that online to our platform for processing. And then that'll be basically submitted under a project under your account.
Okay.
Okay, but
Do we kind of
hold on, hold on for 1 second now. You have to do the processing and the registration of all the individual scans yourself, correct?
So the registration happens through your scanner,
Right. Okay.
like that, and then the
I wanted to
processing
make
is done through us.
Okay, but there's something called pre-processing, which you do before you do the registration, which has to be done by your client. And then Preview takes that registered group of scans, which constitutes the overall point cloud of multiple scans. I just want to make sure that's clear.
Yeah, so we can ingest it as either multiple scans as long as they're structured. All we need really is, just to make it simple, is a structured E57.
Yeah. Okay.
Okay.
Yeah. Sorry, was there a follow-up question that you had?
No,
Yeah,
he
sorry.
asked it.
Okay.
He and I are on the same wavelength, I think. So whatever.
Okay. Yeah. No, they don't do the actual registration. You still would have to do the registration yourself.
Okay, yeah, that was gonna be my question: is do we dump in the raw files, or because there's some
Yes.
software platforms that they claim to kind of do that sort of stuff. We've had issues with that before.
Yeah, no, so using Scene or Cyclone or whatever it is that you
Yeah.
register your scans with, so you would register it to output the structured E57. Once you have the structured E57, we take that file and we create the mesh.
Okay, thank you.
No problem.
Sorry, if I just can ask one question. So can you also add them pod files in here? So we usually use pod files, right?
Pod files?
Yes.
So I'll show. So we can import a lot of 3D objects. So I'll show you in just a moment what we can import. So just to run through some of the basic functionalities here. So anything you want to measure in the space, you can. And so again, this is going to depend on which scanner you use. But with a Leica RTC 360, you get a pretty good margin of error of 2 millimeters. Any surface area you want to measure, also. And then any diameter of any pipe.
Yeah, that's really handy there.
And it's easy to change to metric instead of inches?
Yes, yeah. So that was when I was logging in. So when you launch a project, every time you're opening up the project, you can decide the level of quality you want it to be defined at for that instance that you're running it, and you could decide if you want to measure things in feet or in meters, so metric or imperial.
Okay.
And then as far as anyone you invite into the space can also annotate. So what I'm showing you guys right now, these are functionalities that can be accessed by anyone that you've created a link to that accesses the space. This is not restricted to anyone with a design license. So this is, very, very accessible to even if you have one design license. Anyone who you invite into the space can measure, can annotate. And this is what an annotation looks like. Essentially, you describe something in the space. So in this case, a chiller. Let's just say to be moved next week. And I can start attaching files, URLs, sounds, and this can all be easily done by anyone that you invite into the space. So the next step of what I'm going to show here is really going to be more in the engineering workflow. So this is what you now start requiring a design license for. So imports, for example, if you want to import 2D floor plans, so if you want to bring in your CAD floor plans, your DXF, PNG, and you want to overlay it on the as-built, you can do that here, or you can export it and do it in CAD, whichever one's most convenient for you. And then for 3D models, anything you want to bring into the space, we're very agnostic with. So you said pod. I've never heard of that as a 3D object, but we do take OBJs, FBXs, GLBs, STLs, quite a few, right? So RVTs, if you work in Revit, Navis works. So we do ingest quite what I thought was almost all 3D files. So we are generally pretty agnostic with the kinds of files we accept.
So we mostly use Bentley products, the Bentley suite.
Okay.
And yeah, so their point cloud works with port files.
Okay, is there if there's a way to turn that into an OBJ or an FBX or something more industry standard, then we would be able to ingest it that way.
Yeah, I think we get it. We do get it from a scan data. So I think that's where they then choose. Do they want a
Okay.
.port file or what they want? Yes.
Sure. So the next thing I'll show here is, let's just say we want to extract something in the space. If now we're talking, hey, okay, so I want to start creating assets. I want to start classifying assets, maybe attaching metadata to assets. So let's just take this pump here, for example. So, contrast this to how long it might take you to model something. So here I've got the pump. I decide where I want to cut it. I decide the height that I would like to cut it at. And then I can name the object here a little bit higher so I don't extract it with the floor. Call it pump 1. Once I've done that, it'll begin to extract the object out of the space. And
it's only slow like this because if you're doing this yourself, it's quite a bit faster, right?
right, so this is because because I set it at high quality and because I'm streaming to, I think, quite a few people here.
Yeah.
But here now you have the object in the space. I can move it around. I can attach metadata to it here on properties. So we are going to be, so that it's not quite ready yet, but creating templates for all different kinds of assets in facilities. So pumps, motors, chillers, different kinds of piping, so that you could just easily have a template, and then in that template just attach the values relevant to that specific asset. And then you can also search for likenesses of of these different assets. So if you want to find all of the pumps with said qualities, it'll identify them all for you. You can easily track them, as well as IoT information. So having third-party IoT dashboards attached to these assets, so you can get the real-time readings of what's going on the pump, what's going on with whatever asset it is. If there is some sort of historian with a third-party dashboard, we would be able to attach it to this asset. As far as export functions, here, if I want to export this to another third-party software, I can export it as these following formats. So one being USDZ. Main workflow for that would be to bring it into Omniverse if I want to run simulations in Omniverse, OBJs, GLBs, FBX. So we're also quite agnostic in terms of what we can export to. And if I wanted to create, let's say, a basic animation. So just to showcase as well, it does have clash detection, right? It's not Navisworks level clash detection, but it is pretty accurate down to about 3-4 millimeters. You could see where it'll fit in the space, where it won't. Right? So just to give you an idea. And then if you wanted to show your team how you want to move it in the space, you can create an animation that describes that. So any questions about asset creation or attaching metadata to assets?
Can you hear me?
Yep.
Quick question for you. You were talking about class detections. How do you actually set the limits?
So you could set set limits on how close it'll get to something?
No, what it needs to look at and what you need to class detect with, right? We don't want the entire thing. I want an area kind of thing.
Right. So currently we do have constraints that you could set between an object and other objects. But there's the class detection is very basic. It's just telling you, does it fit clearly in the space or is it running into another piece of mesh?
Okay.
Oh, okay,
Yeah.
it's seeing the mesh. So when you're moving that pump to the to the lower right, yeah, it sees that curb that's outlined in yellow
Yeah, so this
for
so this
the
is
chiller. It sees that curb, right?
yeah, it does exactly. So
Yeah.
basically, any point in space that's hit by the laser that then turns into mesh is classified as an object. If it's
Yes.
touching it, it goes red. If it's not, it deems it as open space.
Right. So you can determine if you can remove that piece without having to temporarily move anything else out of the way to get that piece out, because it'll tell you there's a clash.
That's the idea exactly.
Yeah.
Now it's not on the level of clash detection that was just being asked for by the previous gentleman, but it does give
Right.
you a
Yeah.
pretty decent idea if something will fit in the space where you're trying to move it through.
Okay.
Now,
And sorry, I kind of just
no,
got my
not at all.
microphone to start working, so I got a couple of questions that I had lined up for you. When you were doing your import and you were showing the type of files, sorry to go back a little,
Yep.
type of files, I didn't see DWGs on that list, only like step files, and I didn't see an actual DWGs. So it's only an NWD, NWC, right? Or
Yeah, so DWGs are basically DXFs more so for 2D work, right?
okay, yeah, I guess. Mhm.
So that would be here as a
So you'll export
as
out
a
on that disk.
DXF.
You'll export that out so that you can import it. Okay.
Yeah, but yeah, exactly. But yeah, for 3D models, not as relevant. So it would be mostly these. But for the DWG, it would just be instead as a DXF format.
And your export out gives you options right back to RCPs. Was that right?
Yep. Yeah, so you could retransform it into a point cloud.
So it just, but what would change? Let's say what you just grabbed and you moved it and you export that to the RCP. Does that mean it takes that point data and brings it back? Well, I thought it wasn't a point data anymore. It's a surface,
Yeah,
right?
So it'll extrapolate point cloud data from the surface mesh, but there will be some data loss. So it's not going to be the exact same. It's not going to be the same point cloud that you had when we process it into a mesh. It's going to be a point cloud with a bit of data loss compared to the initial point cloud that we processed, because this is a mesh. We're not reading from the original point cloud. It's basically inferring point cloud data from the mesh, which ultimately results in data loss relative to the original point cloud.
Okay, so there's no way to revert back to the original point cloud that was used to create the mesh.
So part of what we're doing right now is we're creating a platform in which we're going to have layouts and accessible versions visible within the platform. So this is actually coming out in Q2, which is the ability to have the underlying actual point cloud living in the space, as well as the BIM file. Any BIM file or any BIM models that you want to bring into the space with associated metadata will be able to live in the space. So you'll be able to revert from point cloud viewer to mesh viewer to BIM file, right? So this will be possible in the very near future.
Yeah, that sounds really interesting because there's some locations in every plant where you do want to have the point cloud
Of course, yeah.
precision. And other
Yeah.
places, it's fine to just be able to see, oh, I can see there's no clash there. But let's say you want to have a tie point. Well, you're probably going to want to be very accurate with that tie point location, if you're bolting up to something existing. So, but only certain parts you need that level of detail, right?
Right.
So-
And for certain purposes, you'll also want the BIM files that were created for these assets or for the entire environment. So we definitely recognize that there's a use and a need for that. So that's why we're pushing the initiative to have that exist in the space as well. So to transition into essentially what was just released very recently. So the ability to start creating complex objects. So as opposed to the object that I just extracted from the space, we just released two tools. So one being the magic wand, which allows us to more easily detect objects in the space. So essentially, you go around, you have this turntable. You can use the turntable to look at objects. You click on it. Once you're happy with how the object is defined, you click next step. And essentially what it does is it'll predefine a box for you to be able to create as an asset in the space. And you'll get these different views, the top, the right, the isometric. And to continue expanding on the asset that you're creating, you can continue to add boxes. So what this does is it allows for the capability of creating complex geometry within the space as an asset. Right, and once I'm satisfied with how the asset is defined, I can hit generate asset. We'll call it piping asset. I can once again attach metadata to it. And currently it hasn't actually extracted it from the space, but it has generated it as an asset. With this, I can then hit export. Here I can define the level of detail I want to export it as. For example, just because often mesh assets can be pretty cumbersome in something like Revit, you might want to do it at a lower level of quality. You hit export, it'll then extract it from the space, and you can decide what format you want to export it as. But here for the moment, it'll be color coded, and you can continue to define many of the assets in the space this way. And it just allows you to be able to start defining assets such as piping or anything with more complex geometry than basically a rectangle.
Does everything that you do live within this session?
So that segues me into layouts. So any iteration that I create, so essentially the original iteration, the original file will always remain as the original, the as built, and any work that I do will then create a new iteration, and it's up to me to decide whether I want to save that or not, right? So I can save this layout that I just created as a new layout. I can hit save. It's not going to overwrite my original. The original won't be overwritten. But essentially, I can save this layout. I can go to Layout Manager, any layout that I've created. I could then click Share. I could publish it online, and I can invite people to that iteration that I've created. So I can create as many iterations as I want of the original environment, depending on what it is I want to showcase to who for whatever reason. Then as well, if I want to navigate the space with an avatar, you can create your own avatar. People you invite to the space can also create their own avatars, and you can navigate the space here and basically see how your avatar moves through the space. If you also want to, for accessibility reasons, see how a wheelchair moves through the space, you can do that. And then if you're an Elon Musk fanboy, you can see how a Cybertruck fits in there. As well, we do have VR capability, right? So you could take the space or take assets in the space, publish them onto a VR headset and access the space in VR. So that essentially concludes the more basic workflows of Prevu3D. Some of the more complex ones will involve actual imports, exports of objects, or bringing things with metadata into Revit. You know, these are some of the workflows that once people have an account with us, we're happy to take you through those, but those take a bit more time. But yeah, that's essentially the presentation into what we do.
Do you have so what happens when you have a scan and it does not have images created with it? So no photos were taken. It was just a point data.
Yeah. So just point data we still need scan locations for geolocation. But essentially pictures are used for colorizing and texturizing the mesh. So it just won't look as close to reality
It'll
as
just look like a
something like
black,
this.
it'll
Do you
just
have
look
an
like a black
example
and
of
white
that?
scan.
So it'll look like it won't look like a mesh like this. Like it won't be this, but it'll be like, it depends if you have the red, green, blue in terms of the scan, right? So if you do, then it'll still be colorized, but it won't be texturized. I don't actually have an example of it currently. And if you don't have the red, green, blue, then it will look something similar to this. So if you don't have red, green, blue in the point cloud and you don't have pictures, this will probably the mesh will look nicer than the actual result, right? So you'd probably want to go into mesh view than into the regular red, green, blue view, because one, it's not going to be colorized, and two, it's not going to have the pictures to texturize, right? So those are two factors that don't have to be present. You don't need to have the pictures. You don't need to have the red, green, blue in the point cloud data, but it will make it look like a better version of reality if you do.
So I'm assuming you don't need color anyway. It could be just a dark scan and it'll be okay with exporting and things like that. Like your view here wouldn't get so dark that you wouldn't be able to select things, right?
No. And if it was dark, you could set it to mesh view, which will still help you better identify the objects in the space. And you could still cut them, you could still attach, do all the same workflows. But, part of the reason that this environment exists is to help people understand the space. The best way to help people understand the space is to have the most accurate representation of the space.
Yeah, but I'm a member of the guy that spoke earlier about power plants and basements and dark and not so
Right.
lit places. So you do deal with it, and I just wanted to see how it
For sure.
how we'll
Yeah.
interact with it. So
Yeah, for example, when we scan, we just scan in black and white because it's twice as fast, which means we get double the data for the same amount of time spent in the field. So
Mhm.
we don't even use color. So
Okay.
I'm assuming what would happen is that you just see this in black and white and shaded, right? If you didn't have the photos because it's too dark.
Yeah. So if you do it in black and white and you don't have photos, then you would see it in black and white. Yeah, and there's a good chance that just using the mesh view will still help you better define objects in the space and see objects in the space than if you were to go into the red, green, blue view, which is this.
Okay.
so
Yeah.
the your surfacing the surfacing creation, right? Like, so that's obviously, I understand you're working with the surface at this point, and now much of the point data is pretty much it did its work, right?
Yeah.
So just as an estimate, I understand that a scan, depending on how hectic around it is, it gives you a size, right? But
Mhm.
I mean, how what do you see time frames for like something that is like 400, 500 gigs
As how
inside of a
fast you.
building? Yeah,
Yes. So time frame as to like from from us
in,
ingesting it to you having a
yes,
deliverable.
yeah,
Yes. Same day.
same day, like
Like for example, you upload
8 day.
depending, like if you were to take a 500 gigabyte file, I don't know what kind of internet connection you have, but however long it takes you to upload that, regardless of that, once you click process and it's processing on our end, sometime later that day or that evening, your project will be ready to go. So the turnaround time, to give you an idea, is about, because with AWS servers we parallelize all of these processes. So we have terabytes of data being processed all of the time on servers in parallel. And so the turnaround time for a terabyte of data is approximately 12 hours.
Okay, I got it. And this pretty much lives with you once it's uploaded then.
And it could live with you too. I mean, you can export it. You could download the file. You can hit download on the offline portion, so you can work on it offline. Now, when you hit download, it's being downloaded as a PVU file, which is proprietary to us and can really only be accessed on our platform. But you could still take this file theoretically, create a global clipping box and extract this as whatever you like. You can extract this as an OBJ file and then have it live offline on your computer, right? So you can own this data, and you can have it live as a PVU file, which is our proprietary file. But that mesh file can only be really accessed on this platform.
Mm-hmm. Okay, and you were, when we just going back on the importing let's say a DXF file, right? I'm bringing Navisworks, I'm bringing it does, as long as everything is modeled in the same location, it should recognize spaces, like something's geolocated and the model is geolocated. How does it know? It recognizes X, Y, and Z locations, I guess.
Yeah. So as far as geolocations, the X, Y, and Z's are mapped out here.
Okay, because
as long as the geolocation of whatever you're bringing in, or for example, if you're exporting it, you can export it with the geolocation attached to it.
So we experimented with VR, right? And one of the ways that we wanted to do it is to kind of show the customer what they want to see, how they can see the new design within scanned. And we were
Mhm.
able to do that, but it wasn't perfect, and we quit with it because it didn't recognize how the Navisworks scale factor was with the cloud. And you're saying with your product, it will all mesh together, and then you can export to a VR
So we take
viewing.
so generally the geolocation that we take is the one that's brought to us from the scanner, right? So it's as long as the one from Navisworks is the same and works with the same system, then it's not a problem.
Got it. That's pretty good, actually. I haven't found a program that has been able to play nice between both. So, okay.
Yeah, I mean we've worked with basically snap to grid and bringing objects with the geolocation, attach them into Revit, and it's not an issue. But our geolocation relies on the geolocation of whichever scanner is used
Yeah,
to
or
take the
registration,
information.
basically.
Exactly. Yeah. All right. So I'll stop sharing. That concludes the presentation on my end.
Well, thank you, Eric. Are there any other questions? It's kind of an esoteric
Hi.
field for, sorry, go ahead.
Hello. Can I ask a question?
Yeah.
Yeah. First of all, very interesting the presentation. I would like to know what I have to do uh, from the deliverable that you give to us to convert it into for example, a pipeline, convert into a Caesar model or any other stress engineering software. So to make an analysis, what are the next steps for that?
So there were various file formats, industry file formats, that you can export to. It just depends if what you're using can ingest any of those file formats, right? So essentially it would just depend on whether you can ingest them. I don't know if you saw the file formats that I could export to.
No, I haven't.
Okay, so I'll quickly show you again here. So
Well, the product, sorry.
Sorry, go ahead.
No, I was going to say that I think the product is more for visualization at the layout and design and conceptualization stage, even though you can bring in a model of something that you've created yourself, but to export from Prevu3D into a format that can be input or ingested by stress analysis software like Caesar 2, I don't know that that's the proper stage of the product.
Yeah,
guess
I'm not sure if it would fit that workflow.
Yeah,
but
I don't think because for the stress analysis, you need the CAD model. You need data from the CAD model that you're creating that's going to be new in the space that you see in Prevu3D. That you can export to CAD software. Okay, well, we'll
Yeah.
see now all the different formats that you can export to.
So yeah, as much as I can do is just show the file formats that we can export to. But whether it fits what you're looking for, I can't say for sure.
Yeah, because I forget the file type, but let's say in Plant3D, you can generate and export a format. Like I said, I forget what it is, that can be pulled into AutoPipe or KPipe or Caesar 2. But then that's another matter where your stress analysis want to create the file themselves because there's always bugs and when it comes in.
So here
yeah.
the file formats for export are OBJ, GLB, FBX, DXF, TXT, STL, PLY, USDZ, and RCP.
Yeah, you see, none of that can be ingested by, as you say, ingested by stress analysis software, because stress analysis software is basically, it just points in 3 dimensions for a new pipe that's running.
Right.
So it's not, I don't think it's really possible.
Yeah. So I guess maybe it doesn't fit the workflow for stress test because I believe it's, if I'm not mistaken, that's a very specialized function.
Yeah, it is. One question I had is that who is the typical operator of the software? That's why it interested me with regards to SPED, because it seems to me that your typical SPED member or piping designer would be the perfect type of person to operate this software. Who are you finding is doing working with it? Because it's a little bit kind of maybe too detail oriented for engineers to do.
So it has a few different personas. I would say the ideal persona would be an asset manager or someone who a design layout specialist who wants to communicate different iterations of the facilities. Often it's plant managers who manage their plant and want to move assets around, bring in new assets. But really it's anyone that has an interest in understanding how an asset is going to be designed and what kind of data these assets are going to have attached to them. So one of the new emerging job profiles that we see very often associated that want to have a say in our software is VDC, so virtual design construction managers. And I would imagine anyone who has an interest in the design of piping. So I would say now that we have created these new tools to create more complex assets, piping is now a big factor in our tool set, right? So creating new iterations of piping designs, and anyone who's responsible for that could have an interest in our software.
Well, that's what I was thinking, because the piping is usually the biggest pain to try to follow, in the field and what have you. And if you have an easy to navigate model, mesh model based on a point cloud, it makes things much easier. And you need somebody who kind of knows piping the guy who knows piping can also figure out the equipment and can also probably do a lot of duct work and establishing what's there and assigning properties to your assets.
Mm-hmm. Yeah, that, and also anyone at companies in manufacturing that have been for a long time working in scan to BIM that realize that they can cut the modeling out and still have a deliverable that does exactly the same thing. So, you know, BIM designers and you know, people who are working in that field are transitioning to Prevu3D instead of continuing their traditional workflow of scan to BIM, because you save a whole lot of time on the modeling. Now, there's definitely architects and people who do need the BIM models because that's just the industry standard as it stands. But a lot of people are starting to make the transition to scan to mesh. All right, guys. Well, it's been a pleasure. As far as if anyone wants to follow up on the presentation, you all have my information. If anyone wants to get in touch, please do. I would be happy to either answer any follow-up questions or help anyone who's interested in taking the next step with us start to get set up with us and potentially, you know, start trying to use Prevu3D either on a demo basis or on a more pilot project basis. I'd be happy to help you guys out in that regard.
Thank you, Catherine, for setting up this session. And unless there are any other further questions, I guess we'll call it a day. And
thank you guys so much. I appreciate your time.
Thank you so much, Eric, Paul, and all members. Lovely to see you online.